Today we're going to be solving all different types of log equations. I'm going to show you the 3 different types that we'll be working with, and I'm going to show you how to recognize each different type. There are 3 different types of log equations. The first one we're going to go with is whenever we have all log terms. When each term in our equation has a log term, we're going to condense the left side and condense the right side, so that way we have a log equal to a log. And as long as we have the log and the base on the left side equal to the exact same log with the same exact base on the right side, then we can ignore our logs and our bases and set our arguments equal to each other. Let's take a look at example 1. I have log base 2 of 3 plus log base 2 of x is equal to 2 in parentheses log base 2 of 12 minus log base 2 of 4 plus log base 2 of 3 close parentheses. Well, remember, we're going to have to condense because we want it a log equal to a log. So I'm going to condense the left side, and I'm going to condense the right side. When I condense the left side, I can see that there are no exponents, but there is a plus sign, which means I can rewrite this as log base 2 of, and the 3 and the x are the arguments, but because of the plus sign, when we condense them, we're going to be multiplying them. 3 times x gives me 3x is equal to. Now on the right side, before I condense, I'm going to go ahead and distribute that 2 in front of every log that it belongs to. So I end up with 2 log base 2 of 12 minus 2 log base 2 of 4 plus 2 log base 2 of 3. And so now I have the 2 in front of every log that it belongs to. Well, now I can see that those 2's are really exponents. So I can put the 2 back as an exponent on the 12. I can put the 2 back as an exponent on the 4. And I can put the 2 back as an exponent on the 3. So I would end up with log base 2 of 3x is equal to log base 2 of 12 squared minus log base 2 of 4 squared plus log base 2 of 3 squared. And now I can condense it further. 12 squared, I'm going to change. 4 squared, I'm going to change. And 3 squared, I'm going to change. So I have log base 2 of 3x is equal to log base 2 of 144 minus log base 2 of 16 plus log base 2 of 9. Now, whenever I condense the right side, I can see that there is addition and subtraction. Remember, anytime there's subtraction, we know there automatically has to be a fraction. So I have log base 2 of 3x is equal to log base 2, and I'm going to go ahead and put my fraction. We have to also remember that anytime you have a positive log in front of your argument, that argument is going to go in your numerator. Anytime you have a negative log in front of your argument, we're going to put that in the denominator. So that 144 has a positive log base 2 in front of it. So I'm going to have the 144 in my numerator. The 16 has a negative log base 2 in front of it. So the 16 is going in my denominator. And then that 9 has a positive log base 2 in front of it. So my 9 is going to go in my numerator. And remember, addition tells us that we're multiplying them. So we have 144 times 9. If you were to put 144 times 9, you would get 1,296. And if you were to divide that by 16, you would get 81. So now I have the log base 2 of 3x is equal to the log base 2 of 81. Now I have a log equal to a log. Well, since it's the exact same log with the exact same base, all we have to do is ignore the logs and their bases and set their arguments equal to each other. So I end up with 3x is equal to 81. Now to get rid of my 3, they're multiplying, so I'm going to divide by 3, divide by 3. The 3's go away. I get x is equal to 27 because 81 divided by 3 gives me 27. This is my answer. The next situation that we might run into is that we have no log terms at all. When there are no log terms, we're going to bring the log back. Let's take a look at example 2. I can tell there's no log terms because I don't see any with the word log. So I have 3 times 5 to the x plus 5 is equal to 17. Whenever we have no log terms, we're always going to get it into an exponential equation where my exponential part is on the left side and it's equal to my answer. The exponential part has an x in the exponent. Well, there's my 5 to the x. I need to get that 5 to the x completely isolated, so I know I have to get rid of the 3 and the positive 5. I'm going to get rid of the positive 5 first. So opposite of adding 5 is subtracting 5. I have 3 times 5 to the x is equal to 17 minus 5 gives me 12. Now, I still want to get that 5 to the x completely by itself, so I'm going to have to get rid of my 3. While they're multiplying, 3 times 5 to the x, opposite or inverse operation of multiplying is dividing. So I'm going to divide by 3, those go away. I get 5 to the x is equal to 12 divided by 3 gives me 4. Now, since there were no logs in this entire equation, we're going to bring the log back. So I'm going to write log in front of 5 to the x, and I'm going to put it equal to log of 4. Now we're going to use the logarithmic properties to move our x in front of the log it belongs to. So I end up with x log of 5 is equal to log of 4. And now I want to get my x completely alone. Well, we're multiplying x times log of 5. So I'm going to divide by the log of 5. Divide by the log of 5. And when those go away, I get x is equal to log of 4 divided by log of 5. This is one way we can write our answer. The second way that we could write our answer is x is equal to, using that change of base property, we could write log base 5 of 4. This is another way we could write our answer. If you wanted the numerical value, you would just type this into the calculator. The last situation that we'll come into contact with whenever we're solving log equations is when we have a combination of logs and non-log terms. So some of our terms are going to have logs, some of our terms are not going to have logs. What we're going to do is we're going to rewrite as an exponential equation. So in order to do that, what we're going to do is we're going to get it a log equal to a number or a value. And now I'm going to see what I can do. Well, this 2 is being multiplied. Now, normally you want to go ahead and distribute, but if we were to distribute, we're going to end up getting exponents. But another way we could get rid of this is by following our mathematical rules. They're multiplying 2 times that parentheses. Well, the opposite of multiplication is division. So if we do the inverse operation of dividing by 2, that's going to get rid of that 2 that's in front. I end up with log base 2 of x plus log base 2 of 5 is equal to 8 divided by 2 gives me 4. Now I'm going to condense the left side so I have a log. Well, addition tells me that I can multiply. So I can write log base 2 one time, and then I'm going to multiply my x times my 5, because remember, whenever they're adding, we multiply our arguments. So x times 5 gives me 5x is equal to 4. Now we have a log equal to a number. We can go ahead and circle our base in our answer. And this is going to allow us to rewrite this as an exponential equation. The base is 2. That becomes the base of the exponential problem. The 4 becomes the exponent. So there's my 4 is equal to 5 times x. So I end up with 2 to the 4th is equal to 5x. Well, 2 to the 4th in my calculator is going to give me 16. So I have 16 is equal to 5x. Well, if I have 16 is equal to 5x, I know we're multiplying by 5, so I'm going to divide by 5, divide by 5. I get 16 fifths is equal to x. Now, this is my answer. Thanks for watching as we solved all log equations.